Good morning, ladies and gentlemen of Precalculus. Today we're moving on to another portion of our course. It's called Discrete Mathematics. So far we did chapter 1 on functions, chapter 2 on like polynomial functions and zeros and rational functions. Chapter 3 was logarithmics and exponentials. And then here we're advancing to chapter 9, which is discrete mathematics. In this section of the course is the first thing we're going to look at is binomial expansion. And then we're going to later on next week look at sequences and series. And this section of the course is the section that has probably a closely aligned application to computer programming. I don't know, has anybody ever thought about going into computer programming? No? You haven't? Okay, well, I'd like you to consider maybe not being a professional computer programmer, but to know something about programming is going to help most people in their professions from here on out, because it's just becoming a greater and greater portion of what our reality is in this 21st century world. So the skills that we're looking at, the question is often asked, well, what application is there to this particular thing we're working on in real life? Well, in this instance, we're looking at the skills of iterations and following patterns are what have application in computer programming and other things that use algorithms. And something as simple as an Excel spreadsheet, if you think about it, anybody ever done an Excel spreadsheet? You have? Well, that's programming too, right? You're programming, you're putting the formulas in to get the spreadsheet to do certain things for you. That's a basic computer program is what it is. So that's what we're working on. So this section today has to do with expanding binomials, and we should get through this pretty quickly. And you can distribute these, use the distributive property to expand the binomial. So what would that look like? Well, it can take shape a bunch of different ways. One way you can do that is you want to expand this binomial here, which is x plus y squared. You just go like this, and you can just put xy, and then we have x squared, and then this cell's xy, this cell here is xy, and this cell here is y squared. And so what you have is your answer is going to be x squared, and then these two here, the diagonals across here, are like terms, so you have plus 2xy plus y squared. And this also introduces what maybe the most common mistake in algebra is, this one right here. Is quantity x plus y squared x squared plus y squared? No, it's not, because you have these middle terms here. But this is a very common mistake. So what I want you to do is go ahead and work on these. Are there other ways to do the expansion than what I did here? Yes, there are. So I want you to go ahead and work on these others. We'll go through this exercise set really quickly. I think I can choose people for this. Let's do that to help get us through quickly here. There it is. Okay, number 2. I'll just ask you what you got from this. It'll be Karina, all right. All right, Karina, what'd you get for problem 2 here? So a squared plus b squared plus 2ab. And this is correct answer, except usually we want to rewrite this in what we would call standard form. And you're going to see why in a little while why we want to put these in standard form. You see that, Karina? Okay, so let's try to keep that in that form. Thank you. Questions on that? How did you do the expansion? What was your technique? So factoring, did you put like 2 sets of parentheses? Yeah, so she just put 2 sets of parentheses. Okay. Okay, this one here, you'll be able to do the same. So this one here has more complexity, obviously, but we'll see how this goes. And I'll talk about shortcuts too, because they'll be helpful here. Okay, Riley? Okay, let's go ahead. What did you get for this, Riley?
I got 10x squared minus 5xy, and then, or 2, would be minus 10xy, since there's another one.
Okay.
That's one, minus 25xy. Right?
No, it should be 25x squared.
25xy?
5x.
Oh, yeah, okay.
I'll show you a shortcut on this too.
Well, I tried to do the box method, and then instead of multiplying, I accidentally added, so I messed it up.
Okay, so have you fixed it by now?
Yes.
What do you have now?
25x squared.
Okay, let's fix this here, 25x squared. Like that.
And then minus, or plus y squared, I think.
Okay, so is that it? Yeah, that's it. I want to show you a shortcut on this here. That's sort of going to be a little bit of a segue into where we're going today, Monday. Okay. What this is, kind of a shortcut to this, is you can take this one here, you can do first term squared, I'll just say first squared. In the middle, you put 2 times first times last. And then over here on the right, you put last squared, or last squared. So first squared is going to be 5x squared, that's going to be 25x squared. And your second one's going to be 2 times the first times the last. Well, the first times the last is negative 5xy, and twice that is minus 10xy. And then finally you have the last squared. Well, the last is negative y, and that squared is going to be plus y squared. Okay? So that's just be like a binomial expansion shortcut. Okay? So let's go ahead and go to the next one. So the next one we have for this one, another victim, and that person is going to be Nicole, who's out taking a test right now. so we have, these are real people here. Justin, okay, Justin, you're next.
We got 4.
4, yeah. All right, Justin, you got
I got a squared minus 6ab plus 9b.
9B.
Is that right? squared.
9B squared. All right, does that look good? What technique did you use for that?
The square thing.
Oh, so you made out a box method? Okay, good. Yeah, that's a good way to do it. All right, thank you, Justin. Appreciate it. Did we do this much? Do you remember doing this in Algebra 2 last year? I know we did it some, because I've been working on Algebra 2 this way. Okay, next one we have is this one right here. Elizabeth, this is yours. Okay, Elizabeth.
I got 9s squared
9s squared, okay.
plus 12st plus 4t squared. I used the box method.
And she used a box method she went like this, is what you're saying. So she goes like this and puts 3s and 2t here, 3s and 2t, and just worked it out and got it that way, okay? And this one here, it's like, that's 12st. So that's that 2 can look like a z one. Okay? Questions on that one? Okay, next, I'll give this one, I'll choose somebody here in half a minute. We don't have a lot. We got 3 more to choose from here.
Surprised you had such thing in there.
All right. Okay, next we have it's going to be Robert. Okay, Robert. What'd you?
P minus 24PQ plus 16Q squared. Oh. And 9P squared. Minus 24 PQ plus 16Q squared.
Okay, how did you do that one?
I did the shortcut, namely told us the first one's squared and then the other one's,
Okay, then 2 times the first and last.
yeah.
So that way I showed you. Okay, good. All right, real good. Good job. Questions on that one? I think we're coming up to the cubed ones here pretty soon. Yeah, these are the cubed ones. Do you have trouble with these? No? There's a pattern for these too, so I'll choose you. Chloe, you can do this one. Becky, you can do this one. Oh, some of the others. You guys right here. Okay.
Should I just give you the answer?
Yeah, what I'll do is let me spin here, because it's gonna be one of you two. It's gonna be Becky this time. So you know who's next, Chloe, right?
Yeah.
Okay, that's good. All right. All right, Becky, what'd you get for this one?
Cube plus v cubed plus 3u squared v.
Okay, u cubed, you have to slow down, u cubed plus
U cubed plus v cubed
v cubed, okay, v cubed.
plus 3u squared v. Plus 3uv squared.
Okay, and that's gonna be it. Now, one thing that I, again,
How does that work?
I'll tell you in a minute, but let me,
I did the doing to the box, I did the multiplication. Elizabeth did the
so did you
box.
put them out like this?
Yeah, we even,
Yeah, that's what I got. I arranged it differently the other two.
Did I do this right?
That's not. No.
So you did them like this?
Yes. I did the first two and then the last two.
Oh, so you did the first two.
And then I put the.
So the first two you had, the first one you had u squared plus 2uv plus v squared, and then you multiplied all this by u plus v, and then worked it all out and got this. Now again, we're going to go ahead and we're going to try to get these in what we call a standard form of expansion, which is going to be u cubed plus 3u squared v plus 3 v squared, that's uv squared, plus v cubed.
is that the answer?
Yeah, this is the answer right here.
Is there like a shortcut to this one too?
Yeah, there is. And that's part of what we're doing in binomial expansion here. We're getting into the shortcuts, and what this is, I'm going to outline what that is, since it really came with your good question here, Rob. Get one of these here. And it's this. This brings up something that I wore a t-shirt to class yesterday that said Pascal's triangle on it. You remember that?
I just remember the
Yeah,
triangle.
and what it is, I meant to bring that t-shirt here for this class, but forgot to bring it with me today. So what this is when you looked at a binomial expansion by squared, okay, so squared, for squared, we had a pattern of 1, 2, 1. Remember that? 1x squared plus 2xy plus y squared. In this one here, for cubed, which this expression is, we have a pattern of 1, 3, 3, 1. Okay? Now to the first power, there's another pattern, which is going to be 1 and 1. And to the 0 power, there's 1 at the top of the triangle. And so this thing here that I've constructed is called Pascal's triangle, which is a pattern for binomial expansion as we succeed into the different powers of binomial expansion. And so what happens is we have the 1, 3, 3, 1 pattern here, and do you notice the powers of u are decreasing? U to the third, u squared, u to the first, and this last one here, it's invisible, but it's u to the 0 power. And then coming from the left, if you look at v, you have v to the 0, v to the first, v squared, v cubed. And so the u's will descend in power from the highest down to 0, and the v's will ascend in power from 0 to the highest. And so that's the pattern of binomial expansion that we're going to explore and use today and Monday. All right? Did that answer your question a little bit, Robert? Yeah, that was a really good question. I'll give you credit for asking the question to move the class forward. All right. All right, Chloe, you had this one.
B squared
Okay, how about b cubed? How's that?
or A cubed plus C cubed minus whatever. I don't even know what it is.
I did
Okay,
it completely
Is it
different and that is, I didn't get anything that she did.
Squared,
okay, remember we had the 1, 3, 3, 1, right?
yes.
So there's 1, and so the next one is a 3, right? And it's minus because we know we're gonna have alternate signs. So now we put, what's the descending power of b? Chloe, what's this? Chloe, what's b, what's b what? B what? B squared,
Yeah, that works.
c, and then we're gonna have plus, what's the next thing in the pattern? 3, and what's this next thing gonna be?
C,
Okay, it's going to be
B,
b cubed, b squared, b, and this one's going to be c what? C squared, and then we have minus, here's the 1, so that's going to be c to what power? Cubed. And so just following that pattern, you can kind of go, now what happens since you have a minus here in the second term, you can have alternating signs. First one's plus, then minus, plus, and minus. And you can kind of succeed in that direction, okay? So what I want you to do is let's look at 9 and 10. Okay, I want somebody else to do. I'm going to have to get a new wheel here because I've run out of names. I've run out of names here. Now, let's get a new one here. Fresh wheel open.
It's worth it to me, yeah.
Pardon me?
It's worth it to me, yeah.
We'll see. We'll see.
I'm gonna get physically angry.
You're gonna get angry, physically angry. You'll be
I
right.
swear, if it was you, I would have blocked, so.
You'll be right. Yeah. All right, Riley, you got the lucky of the draw again. So what'd you get for this one?
And so I, like, combined, I did it into 2 parts, and then for the first, like, equation that goes on the top of this square, I got 2x squared minus 4xy plus.
Oh, so 2x squared? You mean 4x squared? 4x squared.
Oh, yes.
So 4x squared minus 12xy plus
9.
9y squared, like this. And then you multiply it out again. Is that what you did?
Yes.
Okay. Let's get out this going here. So we get like this. And then over here we get 2x minus 3y. Is that right? So what'd you get here?
The first one I got 8x cubed,
Okay.
and then for that one I got negative 12x squared y.
I'm looking at negative 24.
Negative 24, I'm sorry, that's all I have. And
Okay.
plus 18y squared x.
Okay.
And then for the bottom one, I had negative 12x squared y. And
Okay.
then plus 36x y squared.
Okay.
And then negative 18y cubed. 27. Maybe should have said
27? Yeah, 3, that's right, 27, you're right. So minus 27. Okay, y cubed, all right. And then when we simplify it out, we get 8x cubed, and this one's going to be minus 36 x squared y, and this one's going to be 54 xy squared and minus 27 y cubed. Okay? Is that right? And it may not be apparent, but there's still an underlying 1331 pattern here. And we're going to really kind of explore what that is in the next section. But we're just going this far on this one. Okay. Whose brain is hurting?
Physically. I need numbers for no reason.
What it is that when students would talk about their brain hurting, they say, "Oh no, that's." I used to say, "No, that isn't." But actually, brain hurting is a real thing. Your brain actually can hurt.
It does.
Anybody else's brain hurting?
Mine kind of does.
Your kind of does.
Do you mean kind of? My head's like running through.
Wow. Yeah.
By golly, Miss Moore.
Yeah. But we're going to get into. Wait, Chloe, till we get into the long expansion. Except one thing we're going to do, Chloe, as we get into these things, we're going to bring along the use of the calculator and helping out with some of these expansions, because you can see that if we keep on taking this, it's just going to be more and more. Because right, if these things get to bigger powers and bigger powers, it's just going to get tedious and bigger. And so we're going to cut through some of that using the calculator and Pascal's triangle tomorrow, or maybe even today.
You mean Monday?
Monday, thank you. I meant Monday. You're right.
I think we'll just do Monday.
But even today, we're going to have some time to do this. So Robert, you got the next one here. Now this one here, at least it doesn't have any negative signs to deal with. So what'd you get for this one, Robert?
I just started. 64 m cubed. That's all I have.
Okay, well, here's what you have, is you have plus signs, so you can have plus, you can have plus something, but you're going to have m squared n, right? Something m squared n, then you have plus something m n squared,
And then plus mn squared. Always ready.
and the last one here is just going to be something n cubed, right? So now what you have is you have blanks you can fill in for these.
Are these going in today?
These things here? No, probably not. Then these will be 3 here.
Oh, the last one's 27.
Yeah, last one here will be 27. So Robert picked out the first and the last. You have 3 times. Then what you're going to have is you're going to have this 4 squared, because you have m squared, so 3
12.
times 4 squared times 3. So what's 3 times 4 squared times 3?
3 times 16.
Times 3 is what? 3 times 16 times
144.
144. So 144 will go here. And this one here, you'll have 3 times 4 times 3 squared. 108?
Yeah.
108. Okay, so what it is, I'm trying to mentally lead you through, there's some patterns we can use that'll make these a lot faster. And then for the next section I'm going to give you, we're going to start on today, has to do with using calculators to do expansions of higher power. So basically it is, if you're going to do these like Chloe was saying here, continue to 4th power, 5th power, because you can do them, right?
Yeah, but I don't want
But you don't want to do it, right? So that's what we do. So as mathematicians, that's what we do. We try to use our skills to make things easier eventually.
Did you have a question about this? Are
Yes.
they going in today?
They should go on today, but I have to get.
Will they change my grade?
They probably will. Some. Yeah.
Well, you need to change by 2 points.
I know, I know what you're saying. I know what you're saying. Okay, let's go to, oops. Okay, this next one here, oops, I don't have that up yet. So you have this paper, right? So now, we're going to the next set. So the one that we just finished, you're going to turn that in today, and we're going to get started on this one and make some headway on this one. Well, that's a quick review, that's not what I wanted. I want this one here. Here we go. There we go.
Can we get used to it?
Yes.
6. That is strong.
Let's get these ones here. Yes, you'll need it for this too, because this is one that requires a calculator, because you notice,
That, like, you just type in the calculator and pop it up.
yeah, I'll show you how to do it too. This here. Okay. You have the calculator there, Riley?
Yes.
Good deal. Everybody else has their calculator? You got your calculator, Karina? All right. So here we are, it says expand the binomial using a calculator to find the binomial coefficients. Now I showed you in the last exercise set the beginning of Pascal's triangle, right? 1, 1, 1, 2, 1, 1, 3, 3, 1, right? We could continue this. I want to show you how to put those coefficients in the calculator here. So let's go to the calculator. And what we have, the very first thing we put in our calculator, I'm going to get out of this thing here. Okay, very first thing we put in the calculator is we're going to use something in our calculator called NCR. So it's going to look like this: N, little n, big C, little r. And what this is an acronym that stands for N, choose R. And N is equal to the power of the expansion. So the very first thing I want you to do in your calculator is put in, we're going to the fourth power, so put in 4 like this, okay? So you should just have a 4 blinking on your calculator screen like this. You have that? Okay, what I want you to do next is go to math, and then for math, we're going to go here to the right until we get in this menu, submenu, problems. And then what do we see down here at 3? NCR. So you press 3 and you get this.
I did get that.
That is not what
I
Yeah,
got
that's not
4
what I did.
NCR.
Yeah.
Let's try this again. 4, because it could be 4, and then you go to NCR, math,
Broad.
Yeah, it just
Problems.
pulls up.
And 3.
3.
Yeah.
Okay.
It's not what
It's
we
just this different formula.
Yeah, I think it's just a different.
Yeah, so what it is, it's just, it's a different, it's really a different type of calculator. So 4 NCR, yeah. Okay? And so what I'm going to do for mine, and I think you just put it in here, I've done this on a regular calculator the way you have, and so I'm not 100% sure it'll work the same way on this one.
Well, how do we fix it?
Well, just you put 4 and you put NCR, right?
Yeah.
Did you do that already? Good. The next what I want you to do is take you make a bracket. And to make a bracket, you go second, parentheses like this. And then what you do is you put 0, comma, 1,
Wait, how do you put
Comma. 2, comma, 3, comma, 4, and then you close the bracket. So you press second, close, like this. And then what you do is you press enter, and you get this. Is that what you got? So this is your succeeding pattern, 1, 4, 6, 4, 1. And so now you can use that pattern, and you can write it down if you have a hard time remembering, 1, 4, 6, 4, 1. And so now you can write out your answer that you're going to have 1, a to the 4th, plus how many? 4, a cubed, b, plus 6, what?
AB squared.
A squared, b squared, plus what?
4AB.
4ab cubed, plus how many? 1
1B cubed.
b to the 4th. And so this is your whole expansion right here.
Is that the answer?
That is your answer.
Okay, so
Wait.
Now, what's going to happen is we get different coefficients of a and b. That's going to complicate us a little bit going forward, but we can work through that too. But that's how you get those coefficients of expansion on your calculator. And you're going to see that be especially helpful when we get to the bigger powers. And if you look down the worksheet, you see some bigger powers, don't you? And we won't work every single last one of them out today and Monday, but we'll work a lot of them out. So let's go ahead and get to problem 2. Okay, problem 2. Somebody can do this one. I'll just pick somebody because you know how to do it now. I don't know in my mind what a 6-power expansion is. You did? That's what you call. Okay, it's going to be Elizabeth. All right, Elizabeth. All right. What'd you get, Elizabeth?
I'm still figuring out how to do this.
Okay, well, I'm going to put it in my calculator too. Because I'm going to put 6, and I'm going to go to NCR, Math, and go over here to Problem. And I'm going to go to 3, NCR. Now, one thing you're going to have is your first term is going to be the 0, so 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6, close the bracket, and so we get this. Is that what you got, Elizabeth?
Yeah.
What you got? So 1, 6, 15, 20.
Oh wait, we only have 3 minutes left.
Okay, let me deal with that. That's not your problem, that's my problem. Okay, so what was it? I was interrupted there. 1, 6, 15, 20. So what'd you get, Elizabeth? Plus 6, what?
6, 8 to the 5th.
B. 15,
15, 8 to the 4th power, b squared.
B squared, plus
20, 8 to the 3rd power, b to the 3rd power.
plus 15,
15, a squared, b to the 3rd, 4th power.
plus
6, a times b to the 5th power, plus b to the 6th power.
so that's it. Okay? So we're just going to leave it there today. Thank you for participating in class, and we'll just resume on Monday, and that'll be it.